Express as a single trig ratio tan 3x plus tan x all over 1 minus tan x tan 3x. So we use tan a plus b equals tan a plus tan b all over 1 minus tan a tan b. A equals 3x, b equals x, so that leads to tan of 3x plus x, which equals tan 4x. Find in exact form with a rational denominator the value of sec of 195 degrees. Sec of 195 degrees is 1 over cos of 100. Use the addition formula. We need 195 into two angles that we know the trig values of. So I've chosen to use 150 and 45. 45 hopefully is fairly obvious. 150 you'll discover, I'll show you later, is linked to the angle 30, which we do know. I'm going to use cos A plus B equals cos A cos B minus sin A sin B. So that leads to cos of 150 cos 45 minus sine of 150 sine of 45. Now let's take a look at how cos of 150 links to 30. So you can see here it's just the negative value. Similarly, if we look at a sine of 150, we can see that that is the exact same value as sine of 30. So putting those in, we get minus root 3 over 2 times 1 over root 2 minus 1 over 2 times 1 over root 2, which simplifies to minus root 3 minus 1 all over 2 root 2. We actually want sec, so we want 1 over that, which is minus 2 root 2 all over root 3 plus 1. See how I've tidied up the negatives there. Now if we multiply the top and the bottom by root 3 minus 1, we can rationalise it. And that's going to give us minus 2 root 2 in brackets root 3 minus 1 all over 3 minus 1, which is really just 2. And if we take that a couple of steps further, we finally end up with root 2 minus root 6. Find the maximum value this expression can take and the smallest positive value of x for which this maximum occurs. 3 sin x cos 60 minus 3 cos x sin 60. Factorising, we get 3 brackets sin x cos 60 minus cos x sin 60. And using the addition rule, we can find that that's the same as 3 sin brackets x minus 60. Now, the maximum value sine can ever take is plus 1. And so the maximum of this expression is 3 times 1, which is 3. Now sine is 1 when the angle is 90 degrees. So x minus 60 equals 90 leads to x being 150 degrees. Find the minimum value this expression can take and the smallest positive value of x for which this minimum occurs. 5 cos 2x cos pi over 4 minus 5 sin 2x sin pi over 4. This time we're going to use cos A plus B, which leads to 5 cos of 2x plus pi over 4. So the minimum cos can ever be is minus 1. Therefore the minimum of this expression is 5 times minus 1, which is minus 5. So cos is minus 1 when the angle is pi. So 2x plus pi over 4 equals pi. leads to 2x equals 3/4 pi, which leads to x equals 3 pi over 8. Solve this equation in the interval 0 to 360 degrees. Tan theta minus tan 30 degrees all over 1 plus tan theta tan 30 degrees equals 1. This time we're going to use tan A minus B. So tan of theta minus 30 degrees equals 1. So theta minus 30 degrees equals 45 degrees. We just need to look and see if there's any more in the interval. So we see there's another one here at 225 degrees. So now adding 30 to the other side, we get theta equals 75 degrees or 255 degrees. Prove that sine brackets x minus pi over 6 plus cos x is equivalent to sine x plus pi over 6. Using the addition rules, we find that sine x minus pi over 6 equals sine x cos pi over 6 minus cos x sine pi over 6. Now let's compare it with the end identity that we're looking for. So sine of x plus pi over 6 equals sine x cos pi over 6 plus cos x sine pi over 6. What you can notice is that the first two parts are exactly the same, so we don't want to touch those. We need to show that minus cos x sine pi over 6 plus cos x is equivalent to cos x sine pi over 6. Factorising out cos x, we get cos x brackets 1 minus sine pi over 6. Sine pi over 6 is equal to a half. So that's cos x 1 minus a half. So that's cos x times a half. And as we can see, a half is sine pi over 6. So we've got cos x sine pi over 6, which was what we wanted.